Imagine two celestial dancers locked in a graceful waltz around a much larger star. These dancers are planets, and their elegant movements are governed by the star's powerful gravity. The star acts as the conductor of this cosmic symphony, ensuring that each planet follows its designated path in a harmonious dance. These dancers are planets, and their elegant movements are governed by the star's powerful gravity. The gravitational pull of the star keeps the planets in their orbits, creating a delicate balance that allows them to move in a synchronized manner. This gravitational force is what keeps the planets from drifting away into the vastness of space. Now, picture tiny asteroids sharing the same orbital path as these planets, held in place by a delicate balance of gravitational forces. These asteroids are not just random space rocks, they are part of a larger cosmic dance, moving in harmony with the planets they accompany. They are like tiny partners in this grand celestial ballet, each playing a crucial role in the overall performance. These cosmic companions are known as Trojan Asteroids. They are named after the legendary warriors of ancient Troy, symbolizing their steadfast presence in the orbits of planets. Just as the Trojans were known for their resilience and strength, these asteroids have remained in their orbits for billions of years, enduring the test of time. Trojan asteroids are like cosmic hitchhikers, sharing the same orbital path as a planet but staying a safe distance ahead or behind. They are found in two specific regions along the planet's orbit, known as the Lagrange points. These points are like cosmic rest stops, where the gravitational forces of the planet and the star create a stable environment for the asteroids to reside. They gather in specific regions called Lagrange points, where the gravitational pull of the planet and the star creates a stable equilibrium. These points are named after the Italian-French mathematician Joseph-Louis Lagrange, who first described their existence in the 18th century. Lagrange points are unique because they allow objects to remain in a fixed position relative to the planet and the star, creating a perfect balance of gravitational forces. These points, named after the Italian-French mathematician Joseph-Louis Lagrange, act like gravitational sweet spots, allowing Trojan asteroids to remain in a relatively stable orbit for billions of years. The stability of these points means that once an asteroid is captured in a Lagrange point, it can remain there for an incredibly long time, undisturbed by the gravitational forces of other celestial bodies. The first Trojan asteroids were discovered over a century ago, sharing Jupiter's orbit around the Sun. These initial discoveries were made by astronomers who were studying the movements of celestial bodies in our solar system. They noticed that certain asteroids seemed to be following Jupiter in its orbit, leading to the realization that these were a unique class of objects. Since then, astronomers have found Trojan asteroids accompanying other planets in our solar system, including Neptune, Mars, and even Earth. Each of these planets has its own set of Trojan asteroids, adding to the complexity and diversity of our solar system. The discovery of Trojan asteroids around multiple planets has provided valuable insights into the gravitational dynamics and history of our solar system. These celestial companions provide valuable insights into the early solar system's formation and the intricate dynamics of planetary systems. By studying Trojan asteroids, scientists can learn more about the conditions that existed in the early solar system and how planets and other celestial bodies have evolved over time. These asteroids serve as time capsules, preserving the history of our solar system and offering clues about its past. For decades, astronomers believed that Saturn, the ringed giant of our solar system, lacked Trojan companions. However, in 2021, a team of astronomers using the Pan-STARRS 1 survey telescope in Hawaii made a groundbreaking discovery, the first ever confirmed Trojan asteroid of Saturn. This intriguing object, officially designated 2019 AQ-37 but more commonly known as Saturn 60, sent ripples of excitement through the astronomical community. Saturn 60 is no ordinary asteroid. Its discovery challenged our previous understanding of Saturn's system and opened up new avenues for exploring the dynamics of Trojan asteroids. Located within Saturn's L4 Lagrange point, which lies 60 degrees ahead of the planet in its orbit, Saturn 60 provides a unique opportunity to study the interactions between a gas giant planet and its Trojan companions. The discovery of Saturn 60 was a testament to the power of modern astronomical surveys and the persistence of astronomers searching for faint objects in the vastness of space. Its existence hints at the possibility of a hidden population of Trojan asteroids around Saturn waiting to be discovered. Where did Saturn 60 come from, and how did it end up sharing an orbit with Saturn? This question has puzzled astronomers and space enthusiasts alike for years. The journey of Saturn 60 is a fascinating tale of cosmic wanderings and gravitational influences. Astronomers believe that this intriguing asteroid originated in the Kuiper Belt, a vast and icy region beyond Neptune's orbit that is home to countless remnants from the early solar system. The Kuiper Belt is a treasure trove of ancient objects offering a glimpse into the primordial conditions that existed when our solar system was just forming. The Kuiper Belt is like a cosmic deep freezer, preserving objects that formed billions of years ago. These frozen relics have remained largely unchanged, providing scientists with invaluable information about the building blocks of planets and other celestial bodies. These objects, composed mostly of ice and rock, are leftovers from the planet-forming disk that once surrounded our young sun. This disk was a swirling mass of gas, dust, and ice, gradually coalescing into the planets, moons, and other bodies we see today. The Kuiper Belt objects are like time capsules, holding secrets of the solar system's infancy. Occasionally, gravitational interactions between these objects or the influence of passing stars can nudge some of them out of their distant orbits. These interactions can be subtle or dramatic, sending objects on new trajectories that can take them far from their original homes. Saturn 60 likely embarked on a long journey inward from the Kuiper Belt, its path influenced by the gravitational pull of the giant planets. As it traveled through the solar system, it encountered the gravitational fields of Jupiter, Saturn, and other massive planets, each interaction altering its course. As it ventured closer to the Sun, Saturn's gravity captured it, guiding it into its current Trojan orbit. This capture was not a simple process. It involved a delicate balance of forces, with Saturn's gravity gradually pulling the asteroid into a stable orbit. This capture event, a testament to the intricate gravitational dance of our solar system, transformed Saturn 60 from a wandering Kuiper Belt object into a permanent resident of Saturn's L4 Lagrange point. The Lagrange points are regions of space where the gravitational forces of two large bodies like Saturn and the Sun create a stable environment for smaller objects. Saturn 60 now resides in one of these points, a cosmic dance partner in the grand ballet of our solar system. Section 4. Trapped in a gravitational waltz, Saturn 60's unique orbit. Saturn 60's orbit is a delicate balancing act maintained by the gravitational tug-of-war between Saturn and the Sun. This intricate dance is a marvel of celestial mechanics, showcasing the delicate balance that governs the movements of objects in our solar system. As a Trojan asteroid, it resides within Saturn's L4 Lagrange point, a region of gravitational stability located 60 degrees ahead of the planet in its orbit. These Lagrange points are fascinating regions where the gravitational forces of two large bodies like Saturn and the Sun create areas of equilibrium. Imagine Saturn as a giant clock face with the Sun at its center. The concept of Lagrange points can be visualized as specific hours on this cosmic clock, where objects can remain in a stable position relative to Saturn and the Sun. Saturn 60 would be located at the 4 o'clock position, always maintaining a 60-degree angle ahead of Saturn as they both orbit the Sun. This consistent positioning is a result of the gravitational forces at play, ensuring that Saturn 60 remains in a stable orbit. This stable configuration allows Saturn 60 to remain in a relatively fixed position relative to Saturn, like a loyal companion accompanying the ringed giant on its journey around the Sun. This companionship is a beautiful example of how gravitational forces can create long-lasting relationships between celestial bodies. However, Saturn 60's orbit is not perfectly circular. The path it follows is slightly elliptical, meaning it varies in distance from Saturn and the Sun as it travels along its orbit. It follows a slightly elliptical path, oscillating back and forth around the L4 Lagrange point. These oscillations are a result of the gravitational influences of other planets in the solar system, which can cause slight perturbations in its orbit. These oscillations, caused by the subtle gravitational influences of other planets, give Saturn 60's orbit a slightly wobbly appearance. This wobble is a testament to the dynamic and ever-changing nature of our solar system, where even small gravitational forces can have noticeable effects. Despite these minor deviations, Saturn 60 remains securely trapped within Saturn's gravitational embrace, its orbit a testament to the intricate dynamics of celestial mechanics. The stability of its orbit, despite the wobbles and oscillations, highlights the delicate balance that governs the movements of celestial bodies in our solar system. The story of Saturn 60 is a fascinating glimpse into the complex and beautiful dance of celestial mechanics. It reminds us of the incredible forces at play in our universe and the delicate balance that allows objects to maintain their orbits over vast periods of time. As we continue to study these celestial phenomena, we gain a deeper understanding of the intricate relationships between the objects in our solar system. Saturn 60's unique orbit is just one example of the many wonders that await us in the vast expanse of space. Section 5. Echoes of the Past, Unveiling the Solar System's Formation. The discovery of Saturn 60 is more than just an intriguing astronomical find. It offers a unique window into the chaotic early days of our solar system, when planets were still forming and migrating, and asteroids were flung about like pebbles in a cosmic game of billiards. By studying the composition and orbit of Saturn 60, astronomers can glean valuable clues about the conditions that prevailed during the solar system's infancy. The asteroid's composition, likely rich in ices and volatile compounds, provides a snapshot of the primordial material that existed in the outer solar system billions of years ago. Moreover, Saturn 60's capture as a Trojan asteroid hints at the complex gravitational interactions that shape the architecture of our solar system. As planets migrated and interacted with each other, they scattered smaller objects like asteroids, sending some hurtling inward and others outward. Saturn 60's capture suggests that such interactions played a crucial role in populating the Trojan asteroid populations we observe today.